Hi everyone, Mr. Rowe here. I hope everybody's doing well. We're kind of getting to the end of this unit. Hopefully you've been working through this unit on trigonometry. I know I cut out a few things, so hopefully it wasn't too bad. No one really messaged me too much about it, so I can hope and assume that it's going well. The video lesson I wanted to do for this unit would be on these trig identities. So it's something that none of you have ever done before, for sure, and you'll need it for if you go on to take advanced functions. You'll see this again, so it's definitely important that we get introduced to this. And unless someone's kind of walking you through this, I can understand completely how this would be difficult to understand. So I'm going to kind of explain this. And I'm actually going to go through both the lessons today. So there's a trig identities day 1 and day 2. So I'm gonna go through both of them. So I'm not sure how long this video will go. Again, I'll try to make it brief, as quick as possible, because you can always pause it, rewind, go back, watch it again. But hopefully this helps. So trig identities, all you're doing really is it's going to give you an expression such as this, and it wants you to prove that the one side equals the other side. So this is saying, if you take the cos of an angle and multiply it by the tan of that angle, will it equal the sine of that angle? And it's telling you this is true. So all you're being asked to do is prove it. And you're going to prove it using these, what they call identities. So these you've never seen before. This is cosecant, this is secant, and this is cotangent. And what these are the reciprocals of sine, cos, and tan. So if you have sine theta, for example, the reciprocal of this means if I switch the numerator and the denominator, this is the reciprocal of sine theta. Well, this has a special name. It's called cosecant. So cosecant, I shouldn't say these are equal, they're not. This is saying if I have sine theta and I do the reciprocal of it, I'm going to get cosecant. So the reciprocal of sine is cosecant. Likewise, if I take cos theta and take the reciprocal, that has a special name too, called secant. And the reciprocal of the tan function, 1 over tan theta, theta is just an angle, is cotangent. Okay. Now, normally when I teach this in the classroom, I prove a lot of these things to you. I never like to just say, hey, by the way, this equals this. Just take my word for it. There are proofs of this. You could probably find them in your textbook, or if you're really interested, you could just go on the internet and say prove that sine squared theta plus cos squared theta equals 1, and you'll see the proof using the Pythagorean theorem. But we're just gonna get to the meat of this and focus on what you really need to know, not only for this course, but if you continue on in advanced functions. So for example, it is true that if you take sine of an angle and divide it by the cos of that angle, cos theta, it equals the tan of that angle. Again, I have a nice proof that I usually do of this, but we're going to just accept this as fact. And because cotangent is reciprocal of tan, the reciprocal of this, if I interchange the numerator and the denominator, is cos theta over sine theta. And then lastly, if you take sine squared theta plus cos squared theta and add them together, it's going to equal 1. There's also some rearrangements of this. So for example, I could have sine squared theta equals 1 minus cos squared theta. If I isolate cos squared theta, If I bring that sine squared theta over the other side, or subtract sine squared theta from both sides, I'm going to get 1 minus sine squared theta. So these are the identities. At the end of the day, you need to memorize these. You just need to know them. And we're going to use them to make our proof. We're going to prove that the left side equals the right side. So here's a few rules or suggestions and tips. So you're going to usually select the most complicated side to work on. Ideally, you want to put everything in terms of sine and cos. And then there's other techniques you can use that are in play, such as factoring or common denominators, substitution. And we'll see as we go through the examples when those come up. You could also work with both sides, and that's perfectly acceptable, but normally like a solid proof, like a level 4 plus proof, would be just working with the one side, but I have absolutely no problem if you decide to work with both sides. So this is going to start out relatively easy and then build up to tougher problems. So there's no real way to teach this because you have all the information you need. So what I usually do when I teach this, it's in the classroom, is I just talk through my thought process. Like, how are you going to know what to attempt? So, and during this thought process, sometimes it'll take me down the wrong path. Sometimes I'll make mistakes. I might even make some mistakes or run into some dead ends as I'm doing this lesson with you. And that's fine. I don't have an answer sheet in front of me. And that's the way I like it, because if I run into a roadblock or a dead end, then I can talk through, my mindset and how I'm going to get out of that situation. But this is the gist of it. I want to prove that cos theta times tan theta equals sine theta. So I'm going to choose to work with the left side. So this is the left side, this is the right side. So I want to put everything in terms of sine and cos. So what I want to do is, instead of having tan theta here, I'm going to go up here. I see that tan theta equals sine theta over cos theta. So I'm going to substitute that out. So cos theta is going to stay as is, but instead of writing tan theta, I'm going to use one of my identities. So I'm going to substitute out tan theta and put in sine theta over cos theta. So usually what I do when I'm doing these proofs is I go like this. I identify what side I'm working on. So the left side equals this. So what do we have here? We have sine theta times cos theta divided by cos theta. Well, a cos theta divided by a cos theta divides out to 1. So my left side simplifies to sine theta, which is the right side. So this proof is done. Therefore, the left side equals the right side. So I have shown that, using my identities, that cos theta times tan theta equals sine theta. And if you want, sometimes, somewhere along the line someone told me to do this. When you're done a proof, you put this little box with these lines going through it. I don't know, you can do that if you want. But there it is. So all we're going to do is we're going to go through these trigonometric equations and try to do these proofs using these identities. So this looks a little scarier, but we're just going to follow our rules. And this would be a time when, you don't have to, but maybe you'd want to work with both sides. So let's start here. I want to put everything in terms of sine and cos. Sometimes you can work with a side, then you hit a dead end, so then maybe you start working with the other side, and away you go. And I should mention that there's more than one way to do these proofs. So, I could say, hey, everyone go work on this, and someone could try substituting in something, someone could do a totally different way of doing this, and as long as everything makes sense and you haven't gone off the grid, then that's perfectly okay. So there's definitely more than one path to prove these things. But I'm going to work with the left side here. So I have cotangent over tangent. So I know that cotangent, if I go back to my identities here, is cos divided by sine. So it's going to be cos theta divided by sine theta. Now I'm going to divide this by tan theta, and I know going back here, tan theta equals sine over cos. So if you remember how to divide fractions, I'm going to go ahead and divide these. So I have cos theta divided by sine theta. You multiply by the reciprocal of the bottom fraction. So I'm going to multiply by the reciprocal of this. So this becomes cos theta over sine theta. And now if I multiply these together, well, what cos theta times cos theta is cos theta squared, or how they write it, they put the square in front of the angle. It means the same thing. If you take cos theta and you square it, it equals this. This is the notation they use. And you divide it by sine theta times sine theta, which is sine squared theta. So now I have cos squared theta over sine squared theta. So how am I going to make this equal to this? Well, if I go back here and I look at this identity, look what I have here. Sine squared theta equals 1 minus cos squared theta, and cos squared theta equals 1 minus sine squared theta. Those are the exact identities I'm going to use. So cos squared theta, as I just pointed out, is the same thing as writing 1 minus sine squared theta. And sine squared theta is the same thing. It's equivalent to 1 minus cos squared theta, which equals the right side. So I didn't have to work with both sides. And there you have it. I made this, I did all this algebra and rearranging, and I ended up having the left side equal the right side. Alright, so let's go to example 3. How many are there? 4 or 5, eh? Okay. So we'll see. Again, this video is going to be a little bit longer because I'm going to probably go through both lessons, do them all, but you know, if you want to try one and you get it, then you can just fast forward into the video to find a question that you may get stuck on. Alright. So cos squared theta over 1 minus cos squared theta. So first thing you're going to do is look at the question, identify what side you might want to work on. Well, I know it says work with the most complicated side, which would be this one, but it also talks about putting everything in terms of sine and cos. And so that makes me want to work with this side. Or again, you could work with both. So maybe I'll work with both this time, even though I said that last time and didn't do it. This time I will, just to show you that it can be done. So right away I see this 1 minus cos squared theta, and thinking back to this, I know that that equals sine squared theta. So I'm going to go ahead and do that. So I'll leave the cos squared theta on the numerator, and instead of writing 1 minus cos squared theta, I'm going to write sine squared theta. So now I'm going to try to make the left side equal to this. Alright, well I have a cotangent squared theta. Well, cotangent theta is cos theta over sine theta, so cotangent squared theta, would be this squared, and using the quotient law, apply this exponent to the top and the bottom, it would equal cos squared theta over sine squared theta. It would just be like if I took 2/3 and squared it. The answer to this is 2 squared is 4, or 2/3 times 2/3, and then 3 squared is 9. You apply that to both. So I'll get rid of all this. Going back to this, cotangent squared theta is going to be cos theta over sine theta squared, or cos squared theta over sine squared theta. Look at that. one step. The left side equals the right side. So this proof is over. If I didn't want to work with the right side and I just wanted to do one side, the next step would have just been to rewrite sine squared theta as 1 minus cos squared theta. Next example. So now we have nothing in terms of sine and cos. So maybe I'll work with both sides again. So cosecant theta over secant theta equals cotangent theta. All right. Let me work with this left side. So what is cosecant theta? Going back to our identities, that's the equivalent of 1 over sine theta. So this is going to be 1 over sine theta divided by secant theta, which I'm not going to scroll back, but you would see that it is the equivalent to 1 over cos theta. So like last time, I'm going to divide these fractions by going 1 over sine theta multiplied by the reciprocal cos theta. Which equals cos theta over sine theta. Numerator times numerator, denominator times denominator. And I know from back here that cos theta over sine theta equals cotangent theta, which is the right side. So you don't have to put everything in terms of sine and cos. Like I could have made this equal to cos over sine and then made this equal to cos over sine and been done. But you don't have to. This is me just working with the left side and I made it equal to the right side. And I usually like to do a little therefore the left side equals the right side. And then finish the proof. Done. Alright, next one. Well, first thoughts is I'm not going to work with the right side. There's not much to do here. I see a 1 minus cos squared theta. That's familiar. I know that that equals sine squared theta, so maybe that's a good place to start. And there's not really much else I can do here. So I'm going to work with the left side. And sometimes you just got to try things out and see what happens. So 1 minus cos squared theta is sine squared theta. Now, what can we do here? If I were to read this to you, this says sine squared theta times 1 plus cotangent squared theta. Well, all these things you've learned in the past, such as the distributive property, factoring, they're all in play. So again, I'm not sure this is going to work. I'm going to give this a try. I'm going to go ahead and do a distributive property. Alright, well this definitely doesn't equal anything close to 1 yet, but I also know that cotangent theta equals cos over sine. And like in this last example, or 2 examples ago, cotangent squared theta, if this is true, that's the identity. Well, then if I square this, I guess I'll just do it up here. It's going to be this squared. Then cotangent squared theta equals cos squared theta. over sine squared theta. So this is the identity that I'm going to put into this. And again, we'll just kind of see what happens. Sorry, I made a little mistake here. When I distributed sine squared theta, that should be squared. I just looked up and saw that now. So you definitely don't want to be making little mistakes like that, but it's a good thing I caught that. A very good thing, because the next step would have been very confusing. So when I make this substitution, well, now I have a sine squared theta divided by a sine squared theta. I could divide that out, and I'm just left with sine squared theta plus cos squared theta. And as we know, or will know once you've memorized all these identities, sine squared theta plus cos squared theta equals 1. Sine squared theta plus cos squared theta equals 1. So therefore the left side equals the right side. There you have it. So try all the homework. There's some homework on the next page here, plus there's the textbook stuff as well. I'm going to continue this video to do day 2. I'm not doing anything new. It's like it's the exact same thing. It's just there's 2 days of it. So I'm not going to do the recall. This is the exact same as the last box that we did in day 1. I know the identities, so I just won't flip back and say. I'll just put them in and say what they are. So we have 1, 2, 3 examples. Alright, so example 1. So I'm going to prove this. So again, I think I'll be working with the left side here. I'm going to use the strategy of putting everything in terms of sine and cos. It wants to use an x this time. So I know that tan theta, you would have these in front of you with the filled out identities. I guess I could always flip back to here and refer to them. I know that tan theta equals sine over cos. So that's what I'm going to do. Divide that by sine x. So cos divided by cos is gone. So you're left with sine x over sine x. And anything divided by itself is 1. And that proof is done. The thing about these identities that you should keep in mind is that you're never really going to know if it's an easy question or a hard question. Sometimes you could see the scariest looking identity and it could actually be a couple substitutions and it's really easy. Whereas you could see one that doesn't look scary at all and it could actually be quite involved. So you never really know what you're in for until you start trying the question. Alright, so here's an interesting one. I have to prove that cos x equals 1 over cos x minus sine x minus tan x. So somehow I have to make a binomial equal a monomial. So how's that going to happen? So for example, how could I make these two terms, and this is a common theme, a big idea of these identities. How on earth can I make these two terms become eventually one term? Well, hopefully you're saying you would just go ahead and add them. If I add 1/2 to 1/3 by using a common denominator, this will be a little review. The lowest number that both 2 and 3 divide into is 6. Then you're going to write an equivalent fraction here. So 2 times 3 is 6, so whatever I do to the bottom, I'm going to do to the top. So 1 times 3 is 3. And then 1/3, I multiplied the bottom by 2. So I'm going to multiply the top by 2. And then when I add those, I add the top, add the numerators, leave the denominator the same. But the key idea from this, besides just reviewing how to add fractions, is I just took two terms and made them one by adding. And that's kind of exactly what we're dealing with here. So anytime you see that, a common strategy is to add them. And usually one of these will be a fraction. So you can go ahead and do that. And I think that's where this is going. So let me see. I'm going to work with the right side. First thing I'm going to do is put everything in terms of sine and cos. So tan x is the same thing as sine x over cos x. Okay, so you get 1 over cos x. And the idea with these proofs is to show all your work. So I know maybe you could skip steps, but that kind of like in your normal work and get to the answer, but that's totally against what we're trying to do here. The whole purpose is to show your process, to show you can't skip a step. You have to walk it through one step at a time. So sine x times sine x is sine squared x over cos x. So now I need these to eventually become one term. Now look at this. These already have a common denominator, so that's really nice. So I can just go ahead and subtract these. So 1 minus sine squared theta. And does anyone out there remember what 1 minus sine squared theta is equivalent to? 1 minus sine squared theta equals cos squared theta. So I can rewrite this as, I'll just go over here, cos squared theta over cos theta, which are, I guess it's not theta, it should be an x, but I've already made the switch, so we'll just leave that. And if I had x squared divided by x, and I said simplify that, what would you tell me the answer is? It's the division law. You keep the base and subtract the exponents. It equals x to the power of 1. So same thing here. I'm going to keep the base, subtract those exponents. It equals cos theta, or cos x, which equals the left side. Alright, last one here. I'm going to see what I can do here. I have to prove that sine squared theta divided by 1 minus cos theta equals 1 plus cos theta. So, this one is a little tricky. So again, I don't have the answers in front of me, so I'm thinking through it. So what I'm thinking I'm going to do, because it's kind of the only thing I can do, is convert the sine squared theta to 1 minus cos squared theta. So this is a scenario where I looked at this question and I just didn't instantly know what was going to happen. I didn't know instantly where this was going. So I'm just going to try what I can do. There's no identity for this. There's no identity for this. There's one for this. Right here. 1 minus cos squared theta. So that's what I'm going to do. Now, I don't want anyone going rogue here. You cannot just divide these. Okay, if I had like 1 plus x squared, which is basically what this is, divided by 1 plus x, could you divide those out? The answer is an absolute no. Okay, so that's not, we can't just say, oh, this 1 divides out with this 1. That's not how that works at all. So we need something, we need another strategy here. So what I'm going to do is I'm going to look at this. And of course I don't expect you guys to know this already or have even thought of this, but now that you've been exposed to it, it's going to be on the table. And it was briefly mentioned here. If stuck, try to factor. Alright, so going back to this, 1 minus co-squared. Well, what if you saw the question like this? Can this be factored? The answer is yes. If you recall from both this year and last, this is actually a difference of squares. Again, I have no expectation that you would know to do that. But now that we've been exposed to it here, going forward, if you see it, factoring is on the table. Whether it's a difference of squares or just a trinomial, just have an eye out for it. I can factor 1 minus cosquared theta. 1 minus cosquared theta. This is a perfect square. This is a perfect square. And there's a minus sign in the middle. That is a difference of squares. And if you recall how to factor that, you take the square root of the first term, which is a 1. Square root of the second term, which is cos theta. Cos squared theta, square root of that is cos theta, because cos theta times cos theta equals cos squared theta. 1 is a plus, and 1 is a minus. So another reason why, if you've had me this year, last year, I've always harped on you about you have to know how to factor. It's everywhere, and it's not going away, especially in grade 12. And there you have it. Well, look what I have now. I have a 1 minus cos theta on the numerator and 1 on the denominator. Those can divide out. I'm just left with 1 over cos theta. Or 1 plus cos theta, sorry. Which equals the right side. And we're done. So in the last couple of minutes here, I just want to stress to you that this is something that I would normally teach and walk through and have a dialogue with you over 2 to 3 days. So I've done this in a 33-minute video. So we have to keep our expectations in check. I don't expect you to just have watched this video and instantly know how to do identities. That's not how it works. What you're going to have to do to get better at this is you just have to keep practicing all the different questions. They're all going to be unique. When you see your assignment, you're not going to see an identity out of the textbook or from our lesson because there's an infinite amount of them. But what will happen is when you start to do them, you'll start to see trends and tendencies and strategies, like this idea when you see a difference of squares. Well, once you've done that 2 or 3 times, you're going to be a lot more prepared for it. So, and this is something I would say even when I'm teaching it, I would say don't get discouraged, just keep plugging away. And the good thing is you have this video now to at least go back to. I've talked through pretty much all the strategies I think you're going to be exposed to. We had to deal with adding and subtracting some fractions. We had to deal with some factorings, and most of them were just simple substitutions. So give it an honest effort. Don't get discouraged, and definitely message or email me if you have any questions or concerns. But you should be expecting your next assessment to be put out early next week. So that's it for now, and take care.